Have you ever wondered, whether we were really the first? I mean, the first species on this planet to build cities, to command fire, to bend nature to our will. You see, we've always told ourselves that story, that humanity is unique, that intelligence began with us. But what if? Well, what if it didn't? What if, buried deep beneath the layers of time, there once existed another civilization, ancient, forgotten, erased not by myth, but by geology itself? It sounds like science fiction, doesn't it? And yet, the idea has a name: the Silurian Hypothesis, a scientific thought experiment proposed by Adam Frank, an astrophysicist, and Gavin Schmidt from NASA. They asked a haunting question. If there had been an industrial civilization on Earth millions of years before us, would we even know? Would we be able to find their traces? Or would time, pressure, and the slow breathing of the Earth have already swallowed them whole? And that's, the strange beauty of it. Because you see, everything we build, our steel, our concrete, our machines, will vanish in a blink on geological timescales. A few thousand years, a few million tides, and the planet rewrites itself. The only things that last are chemical signatures, the scars in the rocks, the isotopes in the oceans, the rise and fall of carbon in the air. That's the language the Earth remembers. Not monuments, not names, just chemistry. So perhaps we're not asking whether they existed, but whether we're even capable of recognizing them if they did. Because the deeper we dig, the more it seems the Earth holds memories we no longer understand. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. And, I'd love to hear from you. Where are you listening from tonight? It's always fascinating to see who's joining us from all around the world. So let's continue. All right? So it begins with a question that sounds simple, but, echoes through everything we think we know about our place on this planet. What if we weren't the first? What if, well, the story of human civilization isn't the opening chapter of intelligence on Earth, but just the latest one? That thought alone, it twists something deep inside the mind, doesn't it? Because for centuries we've looked at ourselves as the culmination, the final step, the clever species that finally understood the universe looking back at itself. But what if that isn't true? The Silurian Hypothesis, that quiet, unsettling idea proposed by Adam Frank from the University of Rochester and Gavin Schmidt at NASA's Goddard Institute for Space Studies, asks us to imagine the unthinkable. Not as myth, not as legend, but as science. It asks, if there had been an industrial civilization on Earth long before humans, would we even know? And, maybe more importantly, would we recognize it if we found it? You see, the question isn't meant to prove that ancient advanced beings once walked the Earth. No, it's not that. It's meant to explore something subtler, something that reaches beyond history. How civilizations, any civilizations, leave their marks on the planet itself. That's the heart of it. What scars, what traces, what whispers in the rock might survive after everything else is gone? And, well, in a strange way, it's a thought experiment that mirrors our own future. Because one day, millions of years from now, when Earth's continents have shifted, when the seas have swallowed our cities, and glaciers have ground our skylines into dust, what will remain of us? That question, that haunting echo, is what makes the Silurian Hypothesis so powerful. Adam Frank once said that the Earth is a kind of time capsule, a record keeper that forgets almost everything but never entirely. Its layers, like the pages of a slow book, are written not in ink, but in chemistry, in isotopes, in fossils turned to stone. The problem, is that those pages are constantly rewritten. Oceans move, crusts melt, mountains rise and fall. What was once surface becomes buried, crushed, erased. So if a civilization rose and fell, say, 50 million years ago, the odds of finding its ruins are close to zero. That's what makes this hypothesis so provocative. It doesn't ask us to chase myths. It asks us to consider time itself, deep time, not in thousands or even millions of years, but in billions. And, when you really think about that, it humbles you. Because our species, for all its skyscrapers and satellites, has been around for barely the blink of an eye. Let's imagine, just for a moment, how thin our chapter truly is. The Earth is 4.5 billion years old. Life has thrived for more than 3.5 billion. Complex animals appeared about 500 million years ago. Humans, modern humans, have been here for maybe 300,000. Civilization? Less than 10,000. The Industrial Revolution? Barely 300. It's not even a heartbeat on the geological clock. And yet, look what we've done in that blink. We've changed the composition of the atmosphere. We've altered rivers, coastlines, and climates. We've filled the oceans with plastic and the soil with chemicals no volcano or meteor could produce. We've even split the atom. If we disappeared tomorrow, those changes, those fingerprints, would still speak for us long after our buildings had turned to dust. That's the key insight of the Silurian hypothesis. Civilizations, when they reach a certain level of industrial activity, transform their planet in ways that can outlast their own extinction. They leave geochemical signatures, chemical fossils, in the rock, in the sediment, in the ice. And, well, that's what Adam Frank and Gavin Schmidt were really after. They weren't looking for ruins. They were looking for patterns, carbon isotopes, methane spikes, strange metal concentrations, synthetic compounds. They asked, if we can detect the fingerprints of our own civilization in real time, could we, in principle, detect the ghost of another, one that came and went millions of years before us? That question is both thrilling and terrifying. Because if the answer is yes, even in theory, then the next question follows naturally. Where are they? Could the great spikes in CO2 levels recorded 56 million years ago during the Paleocene-Eocene thermal maximum have been natural? Or, well, could they have been industrial? Of course, most scientists would say it's natural, volcanic, biological. The Earth has its own cycles of fire and recovery. But, the pattern, that sharp rise in greenhouse gases, that global warming event that lasted for hundreds of thousands of years, looks eerily familiar. It's like a reflection of our own Anthropocene in the deep past. And that's the unsettling beauty of this hypothesis. It doesn't claim, it suggests, it doesn't shout, it whispers. It tells us, if you want to find the evidence of others, look at yourselves first. Because we, too, are leaving a trail, a geological signature, a layer in the rock that will one day be studied, maybe by something not human, long after we're gone. Well, that's why the Silurian hypothesis isn't about aliens or lost empires. It's about perspective. It's about seeing our civilization not as unique, but as part of a possible pattern. Maybe civilizations rise and fall across time like waves, each one learning the same lesson, that to harness a planet's energy is to change it, and to change it is to risk losing it. So, When we ask, if we weren't the first, where are the others? Maybe the answer lies buried not in myth, but in geology. Maybe their traces are dissolved in the ocean floor, or folded deep into mountain stone, invisible except to the chemistry that remembers everything. And if that's true, then, we have to face an uncomfortable mirror. Because their fate might be our future. The very signs that would identify them, warming, pollution, extinction, are the same signs we're leaving behind. You can almost hear the irony in it. We search for evidence of vanished civilizations while slowly writing our own into the fossil record. It's not just science, it's a story about impermanence, about how even the greatest achievements can fade into silence if they outpace the balance of their world. That's what makes the hypothesis poetic. It's not a warning shouted from the void. It's a whisper from the deep earth saying, remember all of this, the glass and steel, the lights and data. It's temporary. The rocks beneath your feet have seen it all before. And, maybe that's the real purpose of this idea. Not to prove the existence of ancient engineers, but to remind us that the planet itself is the only archive that never lies. It forgets details, yes, but it keeps essence. It keeps memory in matter. So as we turn the first page of this story, this exploration of what might have been before us, we do it with humility. Because it's not just about looking back, it's about looking forward, about asking, what will our civilization look like when it's gone? What will our chemical fossils say about us? And, somewhere between those questions, the next chapter begins. Not in certainty, but in curiosity. Because to ask if we were the first is also to ask if we will be the last. And that, well, that's where the real story of the Silurian hypothesis starts to unfold. All right? So if Chapter 1 left us staring into that dizzying possibility, that maybe we are not the first, then Chapter 2 asks us to slow down, breathe, and, actually look at the planet itself. Because the Earth, well, the Earth is not just where we live, it's the archive of everything that's ever lived. It's a book, a vast silent book written in stone, in dust, in the faint memory of chemistry. And, like any old book, most of its pages have been rewritten again and again, erased by fire, by pressure, by time. So, the question is not just what stories the planet tells, but what stories it has already forgotten. When we talk about time, deep time, we don't really mean time as humans feel it. We mean something else. Something so immense that, it stops feeling like time at all. 4.5 billion years. That number, it sounds simple enough when you say it out loud, but the scale of it, the distance between then and now, is something our brains can't really hold. We've only been around for a blink, a fraction, the tiniest sliver of the planet's long breath. If you were to compress Earth's history into a single day, humans wouldn't appear until the last second before midnight. Civilization? Well, civilization wouldn't even last a heartbeat. The Industrial Revolution, that burst of invention and fire, would be a spark. Bright, loud, but gone before you could blink. So. When we talk about searching for traces of another civilization, one that might have existed millions of years ago, we're asking to find a spark in a bonfire that's been burning for ages. And the truth, the quiet, humbling truth, is that almost nothing survives that long. Not cities, not steel, not glass. The planet is constantly changing, constantly renewing itself. Mountains rise, oceans fall, continents drift. Every 100 million years or so, the surface of Earth is completely remade. The crust recycles itself through tectonic movement, dragging the evidence of the past down into molten silence. So, even if there had been skyscrapers in some ancient age, they would have melted, dissolved, disappeared into magma long ago. That's the first limitation of geology. It's not memory, it's metabolism. The Earth doesn't preserve, it transforms. What we find, when we dig deep enough, is not the record of what once was, but the residue of what remains stable through unimaginable change. That means if we ever hope to find traces of a lost civilization, they won't be in the form of ruins or tools or machines. They'll be in chemistry, in patterns, in anomalies, in ratios of elements frozen into ancient rocks or deep-sea sediments. And, well, that's the beauty and the frustration of it. Because chemistry remembers differently than we do. It doesn't care about stories or meanings. It only records shifts. A little more carbon here, a little less oxygen there, a sudden layer of strange metals that shouldn't exist in nature. It's a language written in atoms and, it takes a kind of quiet patience to read it. Now, think about it. After just a few thousand years, our monuments already begin to crumble. The pyramids, the Great Wall, our oldest cities, they're all, even now, returning to dust. After 10 million years, they'll be gone entirely. After 100 million, even the continents they stood on might have drifted somewhere else. So, when we ask what a civilization millions of years before us might have left behind, we're really asking what kind of evidence can outlast erosion, subduction, and time itself. And the answer, well, the only answer, lies in geology's most stubborn survivors, the chemical fossils. These are not bones or artifacts, but clues locked in the isotopic balance of the Earth. Carbon, for instance, has different forms, isotopes that tell different stories. When life burns carbon in the form of fossil fuels, it leaves a distinctive signature, a specific ratio that no volcano or natural process can easily mimic. If another civilization burned carbon, changed the air, warmed the climate, that change might still echo faintly in the rock record, even after millions of years. But here's the catch. Nature has its own way of mimicking us. Volcanoes can raise CO2 levels. Ocean currents can shift isotopes. Meteor impacts can scatter heavy metals into the crust. The Earth, in its vast creativity, can produce signatures that look almost artificial. So the challenge is, not just to detect anomalies, but to interpret them, to separate what is natural from what is technological. The planet, you see, is both the author and the editor of its own story. It writes, and then it rewrites. Every page that survives is a compromise between memory and forgetting. The further back we go, the more uncertain the words become. That's why so much of deep history feels like a blur, because it is. After a few million years, the difference between natural, catastrophe, and civilization collapse might vanish entirely. And yet, well, this impermanence tells us something profound. It reminds us that even now, in 2025, our own age is already being recorded in the slow chemistry of the Earth. Each ton of carbon we release, each particle of plastic that drifts to the sea floor, is writing our chapter into the planet's long book. One day, long after we're gone, that layer, thin, bright, strange, will stand out. A geological whisper. Something happened here. It's humbling, isn't it? To realize that all our progress, all our technology, might one day shrink to a line no thicker than a sheet of rock. It's not just humbling, it's almost poetic. We build monuments to last forever, but forever doesn't belong to us. It belongs to the planet. And, this idea, this fragile relationship between civilization and time, is what makes the Silurian hypothesis more than a curiosity. It's not about proving that others came before. It's about understanding what survival looks like in the language of geology. Because, in a sense, every civilization, whether human or otherwise, leaves two kinds of fossils, one made of matter and one made of change. The first fades quickly. The second, if we're lucky, lingers. So, what kind of change lasts? A spike in temperature, a sudden layer rich in metals, a thin deposit of synthetic molecules that no organism could produce. These are the things that survive the burning and the burial. These are the things that whisper of industry, of intelligence, of the manipulation of energy on a planetary scale. But even then, the odds are cruel. Because the longer the time, the smaller the chance. Most sedimentary layers are destroyed or recycled within 100 million years. The ocean floor, constantly renewed, rarely preserves its oldest records. And even where evidence does survive, in the deep crust or ancient basins, it's often hidden under kilometers of rock, unreachable, unreadable. So, maybe the reason we haven't found any sign of them yet isn't because they weren't there, but because the Earth is better at erasing than preserving. That thought, it changes something. It forces us to think of civilization not as permanent, but as an event, a pulse in geological time. We rise, we burn, we fade, and the planet moves on. That doesn't make our story meaningless. It makes it precious. Because to leave any mark at all on a world that forgets so easily, that's rare. That's almost miraculous. And maybe that's why we keep searching. Not because we expect to find another ancient civilization carved in stone, but because we want to understand what survival really means. How much of ourselves the Earth will remember, and how much it will forgive. So when we talk about the planet as a book, as an endless, self-editing manuscript, we're also talking about our place in it, about how brief, how delicate, how reversible our existence really is. That's not a tragedy. It's a truth. A reminder that to endure in any form, we must live with the rhythms of the Earth, not against them. And somewhere, buried deep beneath our feet, maybe the Earth already holds the answer, not to who came before, but to what comes next. A faint signal, a layer not yet revealed, waiting for the next curious mind to ask again the question we're still learning how to pose. What if we were not the first? And what if we are not the last? And that question, well, that question is what will guide us, quietly, inevitably, into the next chapter, where the search for traces of the unseen truly begins. All right. So we ended the last chapter standing at the edge of a question. Not just what the Earth remembers, but what it can still speak after millions of years of silence. If the planet is a book, then Chapter 3 opens with the first traces of handwriting we might still read. Faint, fractured, almost erased, but there. Because you see, civilizations, no matter how advanced, don't vanish entirely. They leave whispers, imprints, tiny scars in chemistry and stone. And those traces, those geochemical signatures, might be the only fossils that last beyond the bones. When scientists talk about industrial fingerprints, they don't mean ruins or relics. They mean the planet's memory written in elements, in ratios, in concentrations, in patterns that don't occur naturally unless something intelligent intervenes. That's what makes it fascinating. Because the Earth, it remembers differently than we do. It forgets shape, but it remembers balance. It forgets faces, but it remembers shifts. The first and most obvious sign of civilization, any civilization, would be the atmosphere itself. Our own age proves this. Look at the air around us. The rise in carbon dioxide, methane, nitrous oxide, all unprecedented in speed, not in existence, but in acceleration. Natural processes change slowly. Industry changes fast. So, if another species had once learned to burn fuel, to reshape its environment for power, that change might echo in the isotopic composition of ancient rocks or ocean sediments. Carbon, especially, tells stories. The light isotope, carbon-12, and its heavier sibling, carbon-13, are used differently by biology. When fossil fuels are burned, they release carbon depleted in carbon-13, shifting the global ratio. That shift, that subtle fingerprint, could persist in sediment layers long after everything else is gone. If someone millions of years from now studied the strata from our time, they'd see it instantly. A sudden, sharp decline in carbon-13, marking the Anthropocene layer. And, if they found something similar millions of years before us, wouldn't they have to ask, what caused it then? But the atmosphere isn't the only witness. The oceans record just as faithfully. They are the great mirrors of planetary change, absorbing heat, carbon, and chemicals in ways that endure. Plastic, for example, that strange, nearly immortal invention, is already becoming part of the seabed, breaking down into microfragments that sink and settle. In time, these will form a new kind of sedimentary rock, a plastiglomerate, where molten plastic binds with sand, coral, and shell. If we found such material from an age long before ours, what would we think? Would we even recognize it as artificial? Or would it seem just another quirk of geology? And then there are the metals. Civilization refines what nature distributes unevenly. Aluminum, for instance, doesn't exist in pure form in nature. It bonds too easily with oxygen. Yet our industries produce it in staggering quantities, scattered now through the crust, waiting to oxidize and rest again. The same with rare earth elements, copper, iron, and alloys that resist corrosion. Over time, these too will oxidize, sink, and scatter, but traces might remain. Microscopic grains of unnatural ratios embedded in future stone. Well, maybe the most haunting trace of all is radiation. Nuclear technology, that brief, terrible mastery of the atom, leaves behind isotopes unlike any found before. Plutonium-244, cesium-137, technetium-99. They're not born naturally on Earth in measurable amounts today. Their half-lives are long enough to persist, faintly, for millions of years. Even after their danger fades, their presence whispers of a moment when intelligence tried to harness the fire of creation. That's a story the rocks will never forget. And yet, here's where it gets tricky. The planet, generous as it is, produces its own illusions. Massive volcanic events can mimic industrial pollution. Methane bursts from melting permafrost can mirror human emissions. The Paleocene-Eocene thermal maximum, some 56 million years ago, saw carbon levels surge, global temperatures rise by as much as 8 degrees, and oceans acidify, all without machines, without cities. So, if we found those traces but didn't know the context, how could we tell the difference between civilization and catastrophe, between industry and eruption? That's the central dilemma of the Silurian hypothesis, not just finding evidence, but recognizing it. It's one thing to read chemistry. It's another to interpret intent. Nature, after all, can look industrial by accident. And, Civilizations, too, can appear natural by the time they're gone. Still, patterns matter. A civilization leaves not just a spike, but a cluster of signals: altered isotopes, synthetic molecules, unusual minerals, radioisotopes, and temperature shifts, all coinciding over a short geological window. When those patterns align, when they compress into a few 1,000 years, that's when we might whisper, "Something happened here." The irony, of course, is that we're already creating the very evidence we'd look for. The Anthropocene layer will be a geological beacon. Future geologists, or whoever inherits the Earth, will find our time unmistakable. Carbon isotopes will plunge. Nitrogen cycles will show artificial fertilizers. Trace metals will spike. Plastic, concrete, and glass will merge into new hybrid materials. And beneath it all, faint radiation lines will trace our experiments with nuclear energy. We're writing our presence into the Earth, not in words, but in chemistry. So, if another civilization once did the same, even briefly, its legacy could look a lot like ours. And maybe that's the most unsettling thought of all. Because if they reached an industrial age, they too might have faced what we now face: the paradox of power and permanence. To change a planet is to risk your own disappearance. To burn the fuel that advances you is to sow the signature of your extinction. It's not just a scientific idea, it's almost a moral one. Every civilization that reaches for energy on a planetary scale seems to write its own epitaph into the geology. Not just us, but any that came before. That's why, the Silurian Hypothesis feels less like a theory about the past and more like a warning from the future. And if we're honest, well, we already see echoes of that warning in motion. The same rising CO2, the same melting poles, the same rearrangement of the biosphere. It's happening now, in real time. That's what makes this so haunting. Because to study what might have been is to glimpse what still could be. But maybe that's the hidden elegance of the Earth. It forgets just enough to begin again. It erases enough to heal, to restart, to give life another chance to rise, and maybe to fall again. The traces we search for from some lost age might not be a mystery to solve, but a mirror to hold. And, that mirror, shimmering faintly between rock and reason, leads us forward. Because if these are the signs that mark the existence of civilization, then the next question, the next step, is to look for times when the Earth seemed to bear such marks before, when the planet itself, for a brief and burning moment, looked as if it had been touched by industry. And, well, that's where the story turns next, toward the ancient epochs that resemble our own too closely to ignore, the times when the Earth looked, strangely, unnervingly, as if it had already lived this cycle once before. All right. So we're standing now where science and imagination meet, looking back not at myth, but at the deep, restless history of the planet itself. The Earth has worn many faces, and sometimes those faces look uncannily like our own. That's what the Silurian Hypothesis dares us to ask. What if one of those ancient faces wasn't entirely natural? If you look far enough into geological time, there's a moment, about 56 million years ago, when the planet suddenly, violently, got warmer. It's called the Paleocene-Eocene Thermal Maximum, or PETM, and, to scientists, it's one of the strangest mysteries in the record. Temperatures soared by 5 to 8 degrees Celsius in just a few thousand years, which, well, geologically speaking, is like the blink of an eye. Carbon dioxide flooded the air, oceans turned acidic, oxygen levels dropped, and life scrambled to adapt. When we study that period, what we find looks eerily familiar. The same atmospheric spike in carbon that we're causing now, the same rapid warming, the same mass disruption of ecosystems. It's all there. The sediment layers from that era tell a story that could be ours. Carbon isotopes shifting sharply, global temperatures climbing, continents reshaping their forests and coasts. So, you can't help but wonder, can you? Could that have been a natural event? Or, could it have been something else entirely? Well, the official answer, of course, is that it was natural. Volcanic activity, perhaps, or methane released from the ocean floor, may be triggered by tectonic change. But, well, the strange thing is how fast it all happened. It's not just the magnitude, it's the tempo. The Earth's own processes tend to unfold slowly, patiently. But here, during the PETM, things moved at a rhythm that feels almost artificial. And that's what caught the attention of Adam Frank and Gavin Schmidt when they first proposed the Silurian Hypothesis. They weren't saying that dinosaurs had factories or that ancient creatures built satellites. That's not the point. They were asking something subtler. Could there be moments in the geological record when the planet looks as if it's been industrialized, even if we can't be sure by whom? When we compare the PETM to today's Anthropocene, the parallels are unsettling. The same carbon isotope ratios, depleted in carbon-13, the same increase in ocean acidity, the same loss of oxygen in deep waters, the same pattern of extinction followed by rapid recovery and diversification. It's as if, the planet has already rehearsed our crisis once before. And if that's true, or even possible, then it changes everything. Because it means, well, that the kind of damage we think of as uniquely human might actually be part of a cycle, a repeating pattern of civilization and collapse written into the deep rhythm of Earth itself. So imagine this for a moment. A species, not human, not even necessarily mammalian, rises in intelligence tens of millions of years ago. Maybe they master chemistry, or electricity, or something stranger. Maybe they burn energy to warm their world, to build, to travel. Maybe they learn too late, as we might, that every spark leaves a shadow. The temperature rises, the oceans turn toxic, the ice retreats, and slowly, inevitably, they disappear. What's left isn't their art or architecture, but a layer in the rock, a chemical whisper saying, "We were here." It's haunting, isn't it? Because if it happened before, it could happen again. The PETM isn't the only candidate either. There are other, smaller events. The oceanic anoxic events, where oxygen in the seas suddenly vanished, leaving strange bands of black shale behind. The Permian extinction, when almost everything died, followed by a surge of carbon and heat. Each of these, in its own way, looks like a world that went briefly mad with energy. A world that, burned itself alive. And yet, here's the twist. Nature can imitate civilization perfectly. Volcanic traps in Siberia or India could have released as much carbon as we've emitted in the last few centuries. Methane from thawing ice could have spiked atmospheric levels just as quickly as fossil fuel combustion does today. The planet doesn't need us to cause chaos. It can do that all by itself. That's what makes the search so difficult. Because, well, the closer we look, the more we realize that the signatures of life and industry overlap. It's not always clear where biology ends and technology begins. A massive algal bloom can alter isotopes in the same way that industrial farming might. Lightning and volcanic ash can create compounds that resemble pollutants. So the Earth, blurs its own evidence. It hides the line between nature and artifice. But maybe that's the beauty of the question, that it can't be answered easily. Maybe it's not meant to be solved, but to teach us how to see. Because by searching the past for others, we're learning how to read ourselves, how to recognize our own signature before it becomes just another line in the rock. And, well, if you look closely, that's what the PETM really gives us. Not proof of someone else, but perspective. It shows us what happens when carbon dominates, when climate shifts faster than ecosystems can breathe, when oceans turn acidic and species vanish. It's a time mirror, not showing us who came before, but what comes next if we don't listen. Still, there's something almost poetic about the idea that the planet might have had its own forgotten civilizations. It forces us to imagine intelligence as a recurring phenomenon, not a singular one. It asks us to think of consciousness not as an accident of evolution, but as a rhythm, one that, maybe, the Earth has played more than once. And, maybe that rhythm explains something else too. Why life always seems to find a way back after every collapse. Not just as survival, but as curiosity. Each cycle of destruction gives rise to new forms, new minds, new questions. It's not just extinction, it's renewal. And maybe intelligence itself is part of that renewal, a pattern that re-emerges because the universe loves to know itself. That's what the Silurian Hypothesis suggests beneath all its science, that the universe might be self-aware in cycles, using different voices each time. Dinosaurs, mammals, humans, maybe even something yet to come. Each builds, each burns, each leaves behind the faint echo of its existence. So when we study the PETM, we're not just studying the past. We're studying the memory of the planet's experiment with intelligence. Whether it was natural or artificial doesn't even matter in the end. What matters is that the planet has been here before, standing at the edge of transformation, waiting to see what survives. And if we, in 2025, are living through the same kind of story, then maybe we're not the first characters. Maybe we're just the latest ones to turn the page. The next chapter, we'll go deeper into that idea, into what really remains when the story ends, and how, sometimes, it's not the ruins, but the chemistry that keeps the memory of a world alive. All right. So we've reached the point where, after wondering if others could have come before us, we have to ask the quieter, heavier question. What would actually remain if they did? Because, well, if cities crumble, if metal rusts, if even bones vanish in the slow breath of geology, then what could possibly endure the drag of time? The answer, though small and subtle, is strangely beautiful. It's the chemistry. The chemistry doesn't lie. It's not the buildings that survive, it's the balance. Not the monuments, but the molecules. Every civilization, no matter how brief, leaves fingerprints on the planet's chemistry. A rearrangement of the elements, a rewriting of ratios, a quiet disturbance in equilibrium that outlives everything else. That is what the Earth remembers. And when we talk about memory, we're talking about layers. Layers of ice, layers of sediment, layers of air trapped in stone. Each one is a thin, shimmering page in the planet's diary. The deeper we dig, the older the handwriting becomes. It's not clear, not perfect, but it's there. In those layers, we can trace volcanic winters, ancient extinctions, asteroid impacts, and maybe If we knew how to read more carefully, we could trace the echo of civilization, one not ours, but forgotten. Well, let's start with what we already know. The physical remains of a civilization, metal, concrete, glass, they're all impermanent. 10,000 years maybe, before most of it collapses. 10 million, and it's gone entirely. Tectonic plates recycle continents. Ice grinds everything down. Ocean currents bury and erase. The surface of Earth, in the long view, is not a museum. It's a palette that keeps repainting itself. So, what's left must hide beneath, in the chemistry of the crust and the air. The rocks, they keep secrets better than any vault. When carbon levels spike, they trap that signature. When oceans warm and acidify, their sediments change composition. When metals spread, they bind with clay and dust and fall to the sea floor, waiting to be compressed into future stone. Those changes, those tiny shifts, are the only permanent testimony of a world that once changed itself. And the most telling of all is carbon. Civilization burns. That's what it does. It transforms stored sunlight into heat, matter into energy, carbon into sky. The isotopic ratios of that carbon, especially the balance between carbon-12 and carbon-13, become skewed, unnaturally light. We've seen it happen in our own time, this slow, unmistakable tilt in the atmosphere's chemistry. It's not just a number, it's the shadow of combustion itself. So if another species once burned fuel, somewhere deep in the past, that imbalance might still whisper from the rocks today. But it wouldn't be alone. There would be other clues. Nitrogen from artificial fertilizers, chlorine and fluorine from plastics and coolants, a bloom of synthetic molecules no natural process could create. The soil would remember them, long after the factories were gone. The oceans, too, would bear the scars. Microplastic dust settling like strange snow upon the seafloor. Microscopic traces of polymer mixed into ancient mud. And then, there's the radiation. That, perhaps, is the clearest signature of all. The 20th century, and everything that followed, has already left behind isotopes that nature hadn't seen for billions of years. Cesium, plutonium, technetium. Their half-lives measure time in whispers, slow decay marking the passage of epochs. Even if every trace of our architecture vanished, the rocks themselves would glow faintly with the memory of our science. So, imagine, for a moment, that such a glow existed in strata far older than any human tool. What would we think? What could we think? Well, maybe that's what makes this thought so fragile. The realization that evidence might already be there, buried not in form, but in pattern. You wouldn't find a fossilized city, but you might find an anomaly. A strange combination of metals, or a thin band of carbon-laced clay, or a sudden surge in artificial compounds no natural cycle explains. The Earth wouldn't show us their faces, only their fingerprints. The irony, of course, is that we are creating exactly such fingerprints right now. Every day, every engine, every field of plastic and steel adds to the record. When geologists of the far future cut into the crust, they will find our century as a bright, distorted pulse, a moment when everything changed at once. They'll see our nitrogen spikes, our rare earth metals, our carbon crash, our radioactive dust. The Anthropocene, that brief geological chapter, will stand out like a flare against the slow heartbeat of the planet. And, well, it won't be just a warning. It will be a mirror. What remains of us will be the same kind of trace we're now searching for in the deep past. That's the quiet symmetry of it. we look for others through the very evidence we're leaving behind. But here's the part that feels almost philosophical. Chemistry may endure, but it doesn't care who caused it. A volcanic eruption, an ancient civilization, a runaway biosphere, all leave similar scars. The Earth keeps the data, but erases the meaning. It remembers what happened, not who. That's why, when scientists look at the Paleocene-Eocene thermal maximum, they can see the warming, the carbon shift, the acidifying seas, but not the hand behind it. It could have been nature, or not. The rocks don't testify, they only record. So maybe the question isn't what evidence remains, but can we ever really tell what it means? That uncertainty, that thin veil between knowing and imagining, is where the Silurian hypothesis lives. It's not just about the past, it's about the limits of evidence itself. And it's also about humility. Because, when we realize how little of ourselves will survive, how even our grandest creations dissolve into atoms, it changes the way we see our place in time. We become, well, smaller, but also more precious. Every choice we make, every molecule we release, becomes part of the record. Every breath adds a line to the Earth's diary. That's why the scientists behind this idea, Frank, Schmidt, and others, didn't just mean it as speculation. They meant it as perspective. By understanding what lasts, we understand what we're doing. If only chemistry remains, then what story do we want it to tell? Will it speak of balance, of recovery, or of excess, of collapse? Because the chemistry will tell the truth long after the storytellers are gone. And, maybe that's the quiet lesson here, that permanence doesn't belong to intelligence, but to the planet. Our wisdom, our art, our ambition, all of it, in the end, dissolves into ratios and residues. But those residues, small as they are, matter. They are proof that something once changed the world, that it didn't just evolve, it acted. So when we peer into the rock and read the isotopes, we're not just looking for the past. We're hearing the faint echo of agency, the moment when a world woke up and began to reshape itself. Maybe once before, maybe now again. And, if there was ever another civilization, if they too altered the chemistry of their home, if they too vanished into the anonymity of stone, then perhaps in some deep layer beneath our feet, their story already lies beside ours, silent but not forgotten. And that possibility, well, that leads naturally to the next question. If the Earth can keep such secrets for millions of years, then why, after all this time, have we found so few? Maybe, just maybe, it's not the evidence that's missing. It's our way of looking. And that, well, that is where the next chapter begins. All right. So if the chemistry doesn't lie, then maybe what hides the truth is the Earth itself. Because, what if the reason we can't find any trace of earlier civilizations isn't that they never existed, but that the planet is just too good at forgetting? That's what makes this part so frustrating. It's not the lack of imagination, it's the lack of survival. You see, the Earth, well, it's not a static archive. It's a restless, living machine. It keeps moving, reshaping, swallowing its own surface. Continents drift, oceans rise and vanish, mountains crumble into sand and reform again. So when we talk about trying to find evidence of something millions of years old, we're not just fighting time. We're fighting the planet's own metabolism. It recycles itself. It eats its history. Most of what we call surface today wasn't even here a few 100 million years ago. The tectonic plates, those slow, grinding rafts of crust, are constantly sinking and re-emerging. The ocean floor, for instance, is reborn every few 100 million years, which means, anything left there before, that is long gone, melted, and folded back into the mantle. So, if an ancient civilization had built its cities along coasts or beneath shallow seas, as we do, all of it would have disappeared long ago, erased without mercy. That's the first great problem. The ocean hides its dead too well. 70% of the planet is underwater, and most of that world is still unexplored. Even now, in 2025, we've mapped Mars more clearly than our own seabed. And, if something as fragile as coral reefs can vanish beneath silt and shifting tides, what chance would an ancient industrial layer have? The sea doesn't preserve, it devours. And then there's the second problem. The fragments that do survive are scattered. A few pockets of sediment, a handful of ancient riverbeds, layers of mudstone or shale that escaped subduction by chance. The geological record, it's like a shredded manuscript. Whole chapters missing, random pages fused together, others burned beyond reading. For every million years that pass, the odds of a clear, continuous record shrink to almost nothing. So even if a civilization did arise long before us, its physical evidence would have to be captured in one of those rare, still pockets of time. A quiet seabed that later hardened into rock, a desert plain untouched by glaciers, a river delta slowly buried under its own weight. The chance of that is, slim beyond measure. And if that civilization lasted only a few thousand years, as ours has so far, the signal it left behind would be a flicker, a single thin layer in a wall of stone stretching for eons. We tend to think that what we build will last forever, that skyscrapers and satellites are monuments to permanence. But the truth is, permanence doesn't exist here. Concrete crumbles in centuries. Steel rusts in decades. Even the pyramids, the great stubborn survivors, will one day dissolve, grain by grain. The earth doesn't preserve, it renews. That's both beautiful and tragic. And there's more. Erosion, glaciation, volcanism. Each acts like a page eraser. Rivers cut through ancient plains, winds grind mountains into dust, ice sheets sweep continents clean. It's not that the planet wants to hide its past, it just keeps moving forward, indifferent. What we call history, it calls weather. That's why, even fossils, the most precious remnants of life, are rare miracles. For every billion creatures that ever lived, only a few ever fossilize. And those that do survive, not as bone, but as impression, as mineral ghost. So, imagine trying to find not bones, but batteries, not shells, but silicon. The odds shrink from impossible to absurd. And yet, the irony is, the more fragile the record, the more it reveals about resilience. Because what remains, even if microscopic, even if chemical, still whispers of what once was. That's why, geologists keep digging, sampling, testing, looking for anomalies in isotopes and compounds, not because they expect to find artifacts, but because they hope to find patterns that shouldn't exist. But maybe, there's another reason it's so hard. Maybe we're not looking in the right way. We look for human signatures, metals, plastics, radiation, combustion. But what if the last civilization didn't use any of that? What if they found energy in a way that didn't scar the planet? We might be searching for smoke where there was only light. It's not impossible. Life could have mastered subtle forms of technology, biological, geothermal, chemical, that left no trace recognizable to us. Not every intelligence must build in steel and fire. Some might have lived in perfect equilibrium with their world, altering it only in ways that blended seamlessly into nature's own design. To us, that would look invisible. To the Earth, it would look natural. So, maybe the real mystery isn't that we can't find them, but that they were too wise to leave a mark like ours. Maybe, the only civilizations that last are the ones that disappear gracefully, dissolving back into the rhythm of the planet instead of fighting it. Still, it's tempting, dangerously tempting, to imagine that absence as proof, that because we can't see them, they must never have been. But science lives in the tension between certainty and possibility. Just because evidence fades doesn't mean events didn't occur. The silence of the record isn't denial, it's invitation. And, well, that's what makes the search for deep-time civilizations so haunting. We're chasing ghosts through layers of stone, hoping that somewhere, somehow, a trace survived the grinding machinery of time. But time, relentless and unkind, turns almost everything into dust, even memory. If we zoom out, way out, beyond the scale of cities, beyond the lifespan of species, the surface of the planet looks like a tide of creation and erasure. Continents split, drift, collide, rebuild. Oceans form and drain. Every 100 million years, the face of Earth changes so completely that no map, no mountain, no coastline survives. In that vast churn, civilizations, if they existed, are less than sparks, flaring briefly and gone. And yet, that very impermanence is what keeps life possible. The same forces that erase also renew. The tectonic cycles that swallow continents also release minerals and gases, feeding the oceans and air. Erosion feeds rivers. Destruction feeds creation. It's not just loss, it's balance. The forgetting of the planet is the price of its rebirth. So, maybe that's the paradox. To be remembered forever, one must leave scars. To live in harmony, one must vanish. The civilizations that endure in stone are the ones that destroyed enough to mark themselves. The ones that didn't, well, we'll never know their names. But what if, somehow, traces do remain? Small, hidden, waiting in the deep ocean crust, or beneath polar ice, or trapped in the mineral seams of ancient seabeds. Not buildings or bones, but molecules. Complex, structured, inexplicable. Discovering even one such anomaly would change everything. It would mean the Earth isn't just home to a story of civilization, but to many, each erased, each reborn. And, maybe that's why we keep searching. Not because we expect to find proof, but because we want to understand our own place in that long, shifting memory. If we are only the latest to rise, then what does that say about our future? Will we too vanish without a trace, swallowed by the same cycles we can barely comprehend? The thought, lingers like a question left unfinished. Because if the Earth hides its past so completely, then our survival, our legacy, depends on how we choose to live within that forgetting. And the next step, well, it leads us straight into the mirror of ourselves, into the lesson buried not in stone, but in the very fossil record we are creating right now. All right. So when we look back at everything we've uncovered, the vanished layers, the restless geology, the fragile clues, it becomes clear that, the story of civilizations isn't just about what disappears. It's about what we're writing right now. Because, well, whether we realize it or not, we are creating our own fossil record. One that, the Earth will carry long after we're gone. That layer we're building, scientists already have a name for it: the Anthropocene. It's the geological chapter that belongs entirely to us. It's not a metaphor, it's literal. A physical mark, a global scar pressed into sediment, ice, and atmosphere. When future geologists, whoever or whatever they may be, cut into the crust millions of years from now, they'll find our story not in words or ruins, but in chemistry. And, what will that chemistry say? It will tell of a species that learned to burn the planet's memory, that dug ancient sunlight from the ground, set it on fire, and filled the air with its ghosts. It will show a sharp spike in carbon isotopes, the same one we've already seen in those ancient thermal events. It will show a sudden spread of metals, aluminum, lead, copper, in patterns no natural process could create. It will show nitrogen spikes from fertilizers, layers of ash from industry, and the unmistakable presence of synthetic molecules, plastics, polymers, fluorocarbons, that never existed before us. The layer will glow, literally, with traces of our science. Radioactive isotopes from nuclear power and weapons, each one a tiny clock ticking through eternity. Even if cities vanish, even if oceans rise, those isotopes will whisper that someone once tried to command the atom. But, it's not just the chemistry that speaks. The fossils of our age will look different too. There will be chicken bones, billions of them, pressed into the soil. The most common vertebrate remains on Earth, a strange uniform species bred for consumption. There will be traces of dogs and rats and humans themselves, scattered among concrete and glass turned to stone. And maybe, there will be fossils of plastic, melted and reshaped by heat, hardened into a new kind of sediment. A human-made rock some future geologist might one day name plastiglomerate. It's strange, isn't it, that we can already see our own extinction from within? We are both the storytellers and the fossils. We're writing our epitaphs into the crust as we speak. And, the irony is that this is exactly what the Silurian Hypothesis asks us to recognize, that we are the evidence we've been searching for. When Adam Frank and Gavin Schmidt imagined an earlier civilization, they weren't chasing myths of reptilian engineers or ancient empires. They were asking, if someone like us had once lived, would we even know? And the only honest answer is yes, if we knew what to look for. And no, because we don't. The Anthropocene layer is our Rosetta Stone, teaching us how to read what civilizations leave behind. By understanding ourselves, we learn to see what time might have erased before. And that's where it gets unsettling. Because when you stand back and think about it, the Anthropocene isn't just a geological layer, it's a warning. It's proof that intelligence can alter a planet's trajectory. We've changed the chemistry of the atmosphere, the temperature of the oceans, the rhythm of seasons. We've turned the biosphere into an archive of our consumption. That's power, but also fragility. It's not just what we've made, it's what we've undone. So, when scientists talk about the Anthropocene, they're not just talking about pollution or plastic. They're talking about the moment a species became a geological force, something that shapes the Earth as surely as volcanoes or tectonic drift. That's, both awe-inspiring and terrifying, because it means we've joined the ranks of natural disasters. We are, in a sense, our own extinction event. And, if that's true, then maybe the real purpose of studying deep time isn't to find others. It's to recognize ourselves before we vanish in the same way. Because that's what time does. It erases. It resets. It moves forward. And well, we have only a small window before the planet folds our chapter back into stone. Still, there's something beautiful in that too. The idea that even if humanity disappears, the Earth will remember us in its own language, in isotopes and layers, in subtle shifts of chemistry. We'll become part of the same pattern we once searched for. Not just a civilization, but a signal. It's not permanence, but continuity. So maybe, this is the true mirror of the Silurian Hypothesis. We imagine the possibility of forgotten worlds, and in doing so, we see how easily we could become one. We see that civilization, any civilization, isn't measured by its survival, but by what it leaves behind, not just physically, but ethically, ecologically, emotionally. The Earth remembers our choices, not just our achievements. And when, future beings, if they exist, study the Anthropocene, what will they think? Will they see us as reckless, as tragic, as brilliant, or as lost? Will they marvel at our technology, our art, our ambition, or shake their heads at the speed of our collapse? The record won't judge, but the interpretation will. And, perhaps that's why this hypothesis matters so deeply. It turns the telescope backward, making us the object of our own study. We become the specimen, the fossil, the question. The more we learn about ancient climate events like the Pitum, the more we see reflections of our own moment. The same rise in temperature, the same acidifying seas, the same mass extinctions creeping quietly through ecosystems. The patterns repeat, as if history or geology or whatever force drives the cosmos can't help but rhyme. And so, we realize something humbling, that we are temporary, but our impact isn't. Every plastic bottle, every burned barrel of oil, every atom split and scattered, it all joins the sediment, forming a permanent dialogue between humanity and the planet. It's not just evidence of destruction, it's proof of awareness, because only a conscious species could leave a signature this deliberate, this global. But, awareness doesn't guarantee wisdom. We know what we're doing, and yet we keep doing it. We know that the carbon curve we draw in the sky mirrors the one from 56 million years ago. And we still press the accelerator. We can predict extinction, and we still build comfort upon it. It's not ignorance anymore. It's inertia. That's what the Anthropocene forces us to face. Not our intelligence, but our restraint. Not what we can do, but what we can stop doing. Because if intelligence always leads to planetary transformation, then maybe the test of evolution isn't creativity, but balance. Maybe the civilizations that survive longest aren't the loudest, but the quietest. And, that thought leads to another. What if somewhere, deep beneath the ancient layers, another species once reached this same crossroads? What if they too faced the same choice? To grow endlessly, or to adapt, to burn their future, or to preserve it? Maybe they chose differently. Maybe that's why we can't find them. Maybe they learned to leave no mark. So, when we study our own geological shadow, we're not just learning about the past, we're learning what not to become. The Anthropocene isn't just a warning label for Earth. It's a message to whoever comes next. This is what it looks like when a species forgets it's part of a system. And, maybe that's where our story has to turn next, toward that difficult, trembling question of what survival actually means. Because it's not just about staying alive. It's about staying remembered for the right reasons. It's about creating a legacy that teaches, not terrifies. And that leads us into the next chapter, into imagining what those who came before or those who might come after, could teach us about living with the planet instead of against it. All right. So if we accept that we are now both the evidence and the warning, then the next step is to imagine what could have come before. Because, well, if the Earth has hosted intelligence once, it could have done so more than once. And, the strange thing is that evolution doesn't forbid it. It simply hides it behind time. When people think of ancient civilizations, they, picture humans. Maybe something like us, building things, dreaming in cities. But the Silurian Hypothesis, that breaks the frame. It asks us to consider that intelligence might not look like us at all. It's not just about humans before humans. It's about minds before memory. So, well, what if there was once another species, not necessarily humanoid, not necessarily landbound, that reached complexity enough to alter the planet? Maybe they lived in the oceans, in warm shallows where life thrived during eras we only know by fossil layers, the Devonian seas, the Carboniferous swamps, the Jurassic forests. Maybe they used energy differently, not through combustion, but through chemistry or heat, tapping into the Earth's own power instead of mining it. And, that's the problem. If they lived sustainably, if their technologies harmonized with the biosphere instead of overpowering it, then we wouldn't find them. They'd vanish, not because they failed, but because they succeeded too completely. A civilization that lives in balance leaves no scar, and geology only remembers scars. The fossil record, gives us glimpses of immense diversity, bursts of innovation followed by mass extinctions. But what if, somewhere in those bursts, there was a flicker? Not just biological evolution, but technological. It's easy to dismiss the thought. Dinosaurs, after all, had small brains, right? But then, well, birds are dinosaurs, and crows can solve puzzles, use tools, even plan ahead. Intelligence is not a ladder. It's a web. It appears, fades, and reappears, shaped by pressure, not by destiny. That's the unsettling part. Evolution doesn't favor intelligence unless it serves survival. We like to think that sentience is the goal of life, but maybe it's just a brief experiment, one of many. It's not the peak of the mountain, it's a clearing between storms. So, imagine a species that mastered energy not through metal, but through biology. Maybe they grew their machines like coral reefs, wove technology into living tissue, powered by photosynthesis or heat gradients. Their cities might have been colonies of bioengineered organisms, their networks silent and invisible. When they died, their bodies decomposed naturally. Their structures melted back into ecosystems. To future eyes, to ours, there'd be nothing left but healthy soil and balanced seas. And, what if intelligence evolved underwater? That changes everything. Fire doesn't burn there. Metal doesn't forge. Electronics as we know them don't exist. A civilization built beneath the sea would have to invent entirely different principles: sound, pressure, bioluminescence. Their technology might resemble biology itself. And when the ocean floor was recycled by tectonic plates, their history would vanish, swallowed whole. We think intelligence must shout, must build monuments, must leave ruins. But what if true intelligence whispers? What if it learns to disappear? The more we imagine such worlds, the more fragile our own seems. Still, the Earth has had billions of years for experiments like these. The Silurian Hypothesis reminds us that we're a recent addition, not the story, but a late chapter. There were eras of warmth, of oxygen spikes, of massive forests that transformed the atmosphere. each of those moments could have given rise to something, not human, not even mammal, but sentient in its own way. And we'd never know. And, maybe that's not a failure of science. Maybe it's humility forced upon us, because we think of progress as linear, but time doesn't move that way. Civilizations, if they appear at all, might come and go like tides. The Earth, patient and unbothered, simply resets. It doesn't mourn what it loses. It just begins again. Well, so, let's ask the question differently. If there were others, how would we recognize them? Not by tools or ruins, but by impact. Could we, detect subtle anomalies in isotopic ratios from ancient layers? Slight chemical imbalances that shouldn't exist? Or maybe molecular patterns, nanostructures fossilized in clay, that hint at synthetic origins? That's the kind of evidence we might already have, but don't yet know how to read. The truth is, our instruments are still primitive compared to the complexity of the Earth. We find what we know how to seek. 100 years ago, we couldn't even detect exoplanets. 50 years ago, we didn't know DNA carried life's code. So maybe, the evidence of deep-time intelligence is already around us, encoded in forms we haven't learned to decode. And there's another possibility. Not that they vanished, but that they transformed. If a civilization reached a point where it could manipulate life at the genetic or atomic level, it might choose to merge with nature entirely. Not extinction, but integration. Over time, its identity could diffuse through ecosystems, not lost, but distributed. Imagine forests designed to think, oceans programmed to regulate themselves. It's not fantasy. It's just a different trajectory of evolution. And, that leads to an uncomfortable reflection. Maybe we are heading in that direction too. Artificial intelligence, genetic engineering, planetary climate control. These are not just technologies. They're ways of rewriting life. Maybe every civilization eventually confronts the same choice: dominate or dissolve. The ones that dominate vanish. The ones that dissolve endure quietly, unrecorded. The irony is, that we only recognize intelligence that mirrors ours. We look for silicon and steel, not synapses and soil. We assume that progress means conquest, but what if progress means disappearance? What if survival, at its highest form, looks like silence? That's the quiet genius of the Silurian Hypothesis. It doesn't ask us to find them. It asks us to rethink what them could mean. Maybe civilization isn't a thing that builds cities, but a phase in planetary consciousness. Maybe the Earth itself evolves through cycles of awareness, each arising, altering, fading, and starting again. So when we, stare into the rock layers and see only chemistry, maybe we're not seeing absence. Maybe we're seeing completion. The final act of an intelligent species is to vanish so thoroughly that it becomes indistinguishable from its world. That's, not failure. That's mastery. But it also forces us to, well, look inward. Because if those ancient civilizations existed and dissolved, what does that say about us? Are we repeating their pattern, reaching brilliance only to erase ourselves? Or could we learn to stay? Could we find a way to evolve beyond consumption, beyond noise, beyond the need to dominate the very planet that gives us life? The lesson might not lie in their disappearance, but in their restraint. The absence of evidence may itself be evidence of wisdom. And if so, then perhaps the real search isn't geological, but morale. We don't just want to know whether others existed. We want to know whether it's possible to exist without collapse. That's the question hidden beneath the hypothesis. Not about fossils, but about futures. And, maybe that's where this thought begins to blur into something more spiritual. A recognition that intelligence isn't rare because it's difficult, but because it's dangerous. To think, to build, to transform. It's to walk the edge between creation and self-destruction. Those who cross too far vanish. Those who balance endure invisibly. So, well, perhaps somewhere deep in the strata of the Devonian or the Permian, there are traces of minds that understood this. Minds that learned to live quietly, to merge with their planet, to leave no wound behind. Not forgotten, just fulfilled. And that thought, that quiet, lingering possibility, draws us forward, doesn't it? Because if the past can hold such mystery, then the future must hold its reflection. Maybe what we call progress is simply the slow remembering of what the Earth already knew. And, that brings us, naturally, to the next question. If the Silurian hypothesis isn't just about Earth, but about life everywhere, then how do we, as explorers of the stars, begin to look for civilizations that don't want to be found? All right. So if we follow that thread, if we imagine what could have come before, then we must also ask, why does this question matter at all? Why does the Silurian hypothesis, hold such weight beyond curiosity? Because, well, it's not just about history. It's about perspective, about learning how to read the memory of worlds. That's the quiet power of it. The hypothesis, in its essence, isn't trying to prove that dinosaurs built cities or that lizards flew spaceships. It's asking something far more profound. How can we, as scientists, detect the fingerprints of intelligence wherever it may arise, even after time has done its work to erase it? It's not myth-making, it's method-making. And, that's where its scientific value truly lies. The Silurian hypothesis challenges us to refine our instruments, not just the physical tools we hold, but the conceptual tools we use to see. It pushes us to ask what a technological civilization really is when stripped of myth, stripped of ego, stripped of human shape. Because, well, if we can't even detect the possibility of ancient industry on Earth, how could we hope to recognize the remnants of civilization on another planet? Mars, for example. Scarred, silent, red. The dust there hides billions of years of geological stories. If a Martian civilization ever existed, whether mechanical, biological, or something stranger, what would be left? Not statues, not roads, but isotopic imbalances, molecular residues, thermodynamic scars in the soil. And that's exactly what the Silurian hypothesis gives us. A framework, a way to train our eyes and instruments to read those kinds of traces. It turns paleontology and planetary science into companions, both searching for life's shadow rather than its light. And in that sense, it changes the whole field of astrobiology. We no longer look for green men or golden cities. We look for chemistry that shouldn't exist, the kind that whispers of intention, of design, a spike in methane where none should be, a layer of synthetic compounds in alien rock, a temperature anomaly that feels engineered. It's not proof, but it's language. And, learning to read that language may be the only way we'll ever find others. So, the Silurian hypothesis, strange as it sounds, is actually a form of planetary humility. It reminds us that our planet's memory is fragile, that even a civilization like ours can vanish without leaving a visible monument. It tells us that if we wish to look for others, in the stars, in the dust, in the strata, we must first learn how to find ourselves. That humility is, essential. Because it's easy to fall into arrogance, to assume we are the first, the only, the inevitable. But the Earth's deep time doesn't care about our pride. It only records what is chemically undeniable. And right now, our record is forming in real time. Every molecule we emit, every alteration we make to the biosphere is a lesson in planetary self-awareness. And yet, the hypothesis isn't just about Earth or Mars. It's about any world that carries life long enough for intelligence to evolve. Think of Venus, now scorched, clouded, toxic, but once perhaps with oceans and gentle skies. What if it too had a brief age of awareness before the runaway heat devoured it? The Silurian hypothesis gives us a reason to look again, not just with wonder, but with pattern recognition. It's not simply searching for others. It's preparing to understand what we might find. Because, when we do look beyond, when our telescopes catch the faint signatures of atmospheres light years away, we will see chemical fingerprints, oxygen, methane, carbon dioxide, dancing in strange combinations. And to interpret those fingerprints, to know whether they mean life, industry, or something else entirely, we need a frame of reference. We need to understand how civilizations imprint themselves on their planets. And, who better to study than ourselves? We are the control group, the living experiment. Our own rise and fall, whether brief or enduring, will teach future astronomers what to seek. Our Anthropocene is not just a tragedy in the making. It's data, rich and telling. It's the clearest example of how intelligence alters planetary chemistry. That's why Adam Frank and Gavin Schmidt approached this hypothesis as planetary scientists, not archaeologists. They weren't hunting fossils. They were building models. Models that describe what happens when a biosphere is pushed out of balance by industry. And those models apply everywhere. So, maybe the greatest scientific gift of the Silurian hypothesis is not discovery, but preparation. It equips us to recognize our reflection, even if it's light years away, flickering faintly in a telescope's lens. But there's a deeper layer to it, too. The hypothesis, in its quiet way, turns science into philosophy. It forces us to face uncomfortable truths about impermanence, about how intelligence may not be rare but fleeting, rising, burning, fading, forgotten. If civilizations are like waves, then perhaps the universe is an ocean of forgotten peaks, each one briefly touching the light before falling back into the dark. And, that thought reshapes how we see life itself. Because maybe the question isn't, are we alone? But how long do the lights stay on before the sea closes over? Maybe we are not the first, and not the last, but just one more in an unbroken sequence of creation and erasure. That's what makes the Silurian hypothesis both scientific and existential. It's not just an inquiry about geology, it's a meditation on mortality. Our species, our cities, our noise, all temporary, all dissolving into the quiet. The only permanence is the planet, and even that changes slower than our dreams. Still, there's hope in it. Because by studying these possibilities, we are, in a way, learning how to last. We are mapping the boundaries of oblivion. And maybe, just maybe, understanding how easily evidence vanishes will teach us how to leave better evidence. Or better yet, how to leave balance instead of scars. And, as our telescopes reach further, as our probes dig deeper, the question grows. Not smaller, but more profound. What if the search for ancient intelligence isn't about the past at all, but about the kind of future we choose to build? Because, well, if every civilization leaves its mark, then we must decide what kind of mark ours will be. So, perhaps the true purpose of the Silurian hypothesis isn't to prove that others existed, but to ask whether we deserve to be remembered. And that, quietly, almost painfully, leads us toward the next chapter, toward what it means to learn from all of this before time writes us out of the story completely. All right. So maybe now it's time to turn the question back on ourselves, not just to wonder about what might have come before, but to ask what we are becoming. Because, after everything we've seen, after every layer and isotope and scar we've left behind, it's clear that the Silurian hypothesis isn't really about the past at all. It's a mirror. It's a way of asking whether we're ready to exist without erasing ourselves. That's the quiet message hidden in the rocks, that civilizations, all civilizations, are temporary unless they learn to live with their planets instead of against them. We have built wonders, networks that stretch across the sky, machines that think faster than our ancestors could have dreamed, cities that glow like constellations seen from orbit. But we've also rewritten the chemistry of air, water, and soil. And, those changes don't fade when the lights go out. So, well, maybe what the Silurian hypothesis teaches us isn't humility before the past, but responsibility for the future. Because if we are the next layer in Earth's long memory, we decide what that layer says. Will it be a warning, blackened with soot, heavy with plastic? Or will it be something quieter, something that speaks of learning, of restraint? The Earth doesn't judge, but it records. It remembers everything we choose to forget. And, that's what makes this moment, this strange, fragile moment, in 2025, so vital. We are standing at the tipping point between being an experiment and being a lesson, between the age of noise and the age of understanding. That balance won't last forever. Climate change, mass extinction, the exhaustion of resources, they're not abstract forces. They're geology in motion. They're the future fossil record taking shape right now. If we fail, we become evidence. If we succeed, we become continuity. It's that simple, and that impossible. The truth is, our technologies have given us godlike power, but not godlike wisdom. We can alter the course of rivers, the temperature of the planet, even the code of life itself. But we, still struggle to alter our habits, our economies, our hunger for more. It's not intelligence we lack, it's perspective. We think we are masters of the earth, but, well, we're still guests here. The invitation can be revoked. And yet, it's not hopeless. The same creativity that warms the planet can also cool it. The same curiosity that built machines of extraction can build machines of renewal. It's not too late. It's just late enough to matter. So, perhaps the Silurian hypothesis is not a ghost story about what's gone, but a guidebook for what comes next. It reminds us that civilizations rise not from strength, but from cooperation, not from dominance, but from balance. The civilizations that endure are those that find harmony between progress and preservation. Those that forget vanish. That's the paradox of being human. We want to leave a mark, but the more we mark, the faster we disappear. We build to be remembered, but the earth remembers through silence, not monuments. Maybe true survival isn't about permanence at all. Maybe it's about integration. It's not about conquering the planet. It's about becoming indistinguishable from it. And, you can already see glimmers of that shift. Renewable energy stretching like green veins through the deserts. Artificial intelligence predicting weather to save crops. Cities redesigning themselves to mimic forests. Breathing, cooling, adapting. These aren't utopian dreams. They're geological acts of mercy. They are our attempt, clumsy but sincere, to stop fighting the planet and start listening to it. Still, listening is hard. It requires silence, and our species is loud. We fill the world with words, with engines, with signals bouncing off the ionosphere. We fear stillness because it feels like death. But maybe, that's the next step in evolution. Learning how to be quiet without vanishing. Learning how to exist in equilibrium, not in escalation. So the question isn't, will humanity survive? It's, will humanity mature? Because survival without wisdom is just delay. The civilizations that came before us, if they existed, might have mastered energy, chemistry, even biology. And yet, they're gone. Their greatness dissolved into soil. What they couldn't master, perhaps, was balance. And that, is where our test begins. We stand at the edge of becoming the very thing we search for. A forgotten civilization. But, well, we also stand at the edge of becoming something new. A civilization that remembers before it forgets. One that chooses to remain visible not through ruin, but through regeneration. That's, what makes this era so strangely sacred. It's not the end of the story. It's the first time we've realized we're writing it. And, well, maybe the true legacy of the Silurian Hypothesis isn't buried in rock, but alive in awareness. The idea that we are not alone in time, that we share this planet with echoes of what came before, and possibilities of what might come after. So, what if we could learn from them? Those hypothetical ancestors, those invisible teachers of the deep past. What if their disappearance isn't a mystery, but a message? Maybe it's saying, don't rush. Don't burn everything you love just to see it shine. Maybe it's telling us that the end isn't inevitable, that collapse isn't destiny, that balance is still possible. And, maybe that's the purpose of remembering. Not to find ghosts, but to find guidance. To know that the line between survival and extinction is written not in stone, but in choice. We have that choice now. We can still change the story. Because the Silurian Hypothesis, in its quiet brilliance, doesn't demand belief. It demands reflection. It asks us to look at Earth and see not a resource, but a relationship. To understand that our existence is geological, biological, and, well, moral. It's not just science, it's stewardship. So perhaps the lesson is this. Civilizations don't truly die when they disappear. They die when they stop listening. And if we listen, really listen, maybe we can hear the faint rhythm of those who came before, pulsing through the crust, reminding us that everything we build, everything we are, is temporary, unless it learns to live. And, that thought, that quiet heartbeat beneath the noise of progress, carries us onward. Not into despair, but into the next question, the one that lies just beyond the horizon. If the story of intelligence is this fragile, then how many other worlds, out there in the dark, are also writing their own stories, waiting for someone to notice before time turns their voices to stone?